So, hi, Andrew. Welcome to Earhex FM. And first, you are a new guest on the show. So, my first question is how you started programming. And so what was your first Hello World and what was your first computer?
That's a long time ago. So, probably about 1982, it would have been a home computer in the UK called Dragon 32. And it would have been written in BASIC, I think. And then I started writing assembler and then did computer science at university and then started working for IBM. So, originally at home.
Oh, perfect. And how old were you?
About 12, something like that.
Hey, cool. So I had ZX Spectrum or Amstrad. This is actually also a UK invention, right?
Yeah, that's right.
Perfect.
Yeah, I think I'm a little bit older than that by probably about 2 years, something like that.
Okay. And do you know Java? So you've wrote some Java code already?
Yes, I've written a lot of Java.
Oh, perfect. When you started with Java?
I'm not entirely sure, actually, because I wrote a little bit at home when it was still very new. So it would have been Java 1.0, I think. And then, kind of around 2000, I started doing it professionally.
Okay.
So I worked on Web Server Application Server. I wrote some of the code in that. But yeah, originally for hobbies, I think.
Oh, interesting. Web Server Application Server. So which part were you responsible, or what was your area?
So we wrote a new JMS provider inside Web Server Application Server version 6. And I was one of the kind of component leads for that. So I was responsible for taking the messages from JMS interface and writing them into the store where we, make sure that we don't lose them if the server crashes.
Okay, funny, because I had my one of the first commercial Java. This was before Java E, but it was a Swing with JMS project for an insurance company. It was around 2000s, and they used MQ Series on the backend on COS or ZOS, and they used MQ client for Java. I think this was the name, and then we switched to JMS because this was just a thin interface or adapter layer above MQ client for Java, and we could use exactly the same technology without being depending too much on the IBM drivers.
Yeah, I understand that stuff. Yes.
Perfect. So now, why I wanted to talk with you is the following situation. So I'm in microservice area with Java E, OpenLiberty. I'm using OpenLiberty, Whitefly, Payara, Tommy, and the application servers. And what people would like to do is to have a communication protocol between their servers. And for unknown reasons, JMS is considered as complicated, or how to call it, or comes with lots of ceremony, which is not true at all. So you can actually send a JMS message with one line of code and receive a message with on-message method. And instead, for instance, they had in-house MQ Series installed, and they say, hey, we just need messaging, but MQ Series is way too complicated for no reasons. And let's switch to Kafka, but we actually don't need persistence in Kafka. We only would like, to exchange message. And what I did several times already, if there's MQS in place, this is really very, very simple to send or receive a message via MQS. And because what you only need it is called, I think, MQRR. This is like the resource adapter. This has to be in the class path, and this is basically it. So then you can send and receive messages. So what do you think that the perception is that the people think or developers think that JMS is too complicated, and they assume that Kafka is more simple?
Yes, it isn't really more simple, is it? So I think it's probably partially fashion. So I think if we're thinking about it in terms of Java Enterprise, then I think that has a bit of a reputation for being kind of complicated and quite a high learning curve. So I think that's part of it. If you're looking at JMS kind of standalone, again, I think it's primarily fashion.
Yeah.
I find that quite a lot of programming or staff which are being employed by companies or being recruited by companies aren't necessarily even Java programmers. So even Java is a little bit like that because, it's quite verbose if you want to just set up a simple class. There's a lot of typing to do that doesn't do very much, like, the public static void main kind of style of thing. And I think it's a similar kind of thing for messaging. It's just kind of, well, I'd like to have something which is a little bit easier to approach and kind of probably a little bit more fashionable. But I think actually writing your first Kafka application is harder than your first JMS application.
Yeah,
because the API is asynchronous and that kind of thing. It's a pretty complicated thing to get right.
Absolutely, and even if you write a Kafka application, I mean, it is. It is. I would say if you know Java, it's simple to set up and to run the application. But the problem is running Kafka in production is a complete different story. And what I see, many projects fail because they start, with Hello World Kafka without any HR, high availability setup, and then they really struggle to have Kafka set up properly in production. So this is also untold story that if you have messaging systems are really hard to scale because you have to know what you are doing, right?
Yes, you need to think them through, don't you, and have a kind of a plan before you get too deeply involved.
Yeah, exactly. And what I already saw is there is something like MQ Lite from IBM. So this is like MQ Series Lite where you can freely download. You know that?
I do know that, yeah.
And is it also available through JMS interfaces or only through the MQ client?
So I think that was kind of a complicated story, and I think it's probably fair to say it's a historical one now. So we were trying to kind of address the fact that the APIs we have with messaging were probably a little bit more complicated than they needed to be. Even though they're not all that hard, if you're new to messaging, then there was a bit of a learning curve. So the idea, and also particularly in microservices environments, you find that different microservice teams choose different programming languages. So we kind of needed an API which was available across a variety of popular programming languages in a kind of in a way that was sympathetic to the expectations of the programmers. So a Node.js version which worked nicely with Node, and a Java version that worked nicely with Java, and one for Ruby, and that kind of thing. And I think in terms of API design, it worked quite well. But in terms of kind of interest after we'd done it, not as successful as we hoped, I think. And then it's supported by the MQ product, by main MQ, but we also tried doing it on the cloud as well. And also trying to use that MQ Lite API on top of Kafka, so that we were kind of abstracting the API away from the messaging engine. And I think experience showed us that the kind of the fit between Kafka and that API wasn't as good as we'd hoped. There's a big difference in the way that Kafka and MQ work, right? And trying to kind of hide some of those differences proved a little bit kind of difficult. Yeah. And then at the end of the day, because Kafka had quite a kind of a surge in interest, then the amount of people with Kafka skills increased at the same time. So it was kind of less advantageous to have a simple API because people knew how to use Kafka directly.
Yeah. Now the question regarding this, is the amount of people increasing who know the Kafka APIs or who are able to run Kafka in production?
I think the skills are increasing quite fast in both of those areas. And there are articles written about how to run Kafka in production, so you can get a bit of a leg up if you're starting from scratch these days, rather than have to roll it all yourself. And there's also all the major cloud vendors have Kafka services these days as well. So if you just want to put your toe in the water, then you can do that with any of the clouds without having to run it yourself.
Yeah, this is actually very reasonable. So don't run Kafka by yourself, just buy a third-party service. Then it's a completely different story. But to creating or setting up Kafka in a microservice project, this is like complete overkill because you will spend at least 1 week with stress tests and with the setup, particularly with Docker or OpenShift-like environments, right?
Yes, indeed. And if you decide to use Kubernetes, then it's even more complicated. Yes, it's kind of a good environment to do it in, but there are complexities to do it, I think.
Yeah. So now I would like to share a short story with you. And it was a young team. They use ActiveMQ, I think, directly with Java. And there was actually a lot of bootstrapping and setup code. And they hired me to help them a little bit. And I took a look at the code and just rewrote everything with a simple Java EE application. And they didn't know what Java EE actually is. And they just, I showed them the code, the resulting code. And they asked me, what is it? And they say, okay, this is just, the old school Java EE. I am just injecting enqueue, sending the message with one-liner, JMS context send message, and you are set. And what they did without my knowledge, they rewrote within 2 days the whole application and run then on Java EE because the code was easier to understand. This is like happened, last year in November, October, around that. And this happens to me over and over again, because if you don't have the server environment, you will have to bootstrap, implement the whole bootstrapping, threading process, configuration process by yourself. And this is lots of bloat.
Yes, indeed. You do get a lot of things kind of done on your behalf, don't you, if you use one of the frameworks? So yes, that's true.
Mm-hmm. And now I'd like to talk a little bit about the differences between Kafka and MQS or JMS. So Kafka for me is actually a complete different architecture. So Kafka is a persistent event store. So I would say the killer use case for Kafka would be like you have a cloud of IoT devices. They're sending you data and you use Kafka as a buffer. So the data remains in the buffer and you can just reread the devices. And JMS or MQS is more like messaging. So it's less about streaming and more about messaging back and forth. And with JMS, so you have point-to-point and publish subscribe. And with Kafka, this is more like publish subscribe is the primary way to go. So there is some overlap, but there is not a lot of overlap. So I would say the whole discussion, so trying to implement with Kafka everything. And as what happens to me, say we would like to use Kafka, but we don't need the persistence. So this is actually a completely misuse of Kafka. So what is actually your take on that?
Yeah, I think you're essentially right. We think of it as there being two different styles of messaging. There's message queuing, which is the MQ and JMS kind of end of things, and there's event stream, which is the Kafka end of things. Architecturally, they're pretty different. And if you think about those two extremes, there are plenty of kind of use cases in the middle where you could kind of make the choice for either technology. You have to write your application in a way which is sensitive to the technology you chose, but you could kind of make either choice. And I think the big difference is that with a Kafka system, it remembers historical data. So if you wanted to run analytics on something which was sent over the past week or something, then Kafka will accumulate that data for you easily without you having to kind of write your applications in a way to not kind of destroy it on the way through. So it's kind of a very good concentrator or a very good buffer or a very good kind of system for events that are kind of moving in the same direction. It's kind of a streaming kind of feel to it. But you really would struggle to write a kind of conversational system using Kafka. Whereas with a message queuing system, that's much, much easier. You can do kind of request reply and the APIs are richer and you kind of get a bit more help if you're trying to do something with your application, I think, with a message queuing system.
This is actually why I invite you to AirHacks FM, because what I see in my projects is everywhere developers try to misuse Kafka exactly for service-to-service communication. Also, for instance, there is already MQ Series installed. Many clients have it on the backend. And why I'm talking about MQ Series all the time, the reason being is regardless whether we use Kafka or JMS, in my point of view, the really hard thing to do is the following. If you think about a queue or a topic, conceptually it is a kind of a distributed singleton. So you are sending the message to something, which is like a conceptual singleton, and if it fails, something different has to wake up and take over the responsibility of the singleton. And this is what you always had to do in order to run MQ systems or messaging systems in a distributed fashion in cluster. So you had to set up multiple nodes, and usually one node is the master and all others are slaves and are waiting until the first node dies, or you have a kind of distributed cache or store. And this is why Kafka is hard to set up. I think the broker proposes about 120 key value pairs, which describe actually the cluster configuration. And also, messaging systems like ActiveMQ or Artemis are also hard to set up because they have exactly the same challenges, right?
Yes, I think that's true. I think that's true. The ones which are kind of single servers are much easier to deal with, aren't they? And if you just want to do a little bit of light messaging, then you just kind of fire a bake process and then you're kind of done.
Yeah, and this is why it actually fails, because setting a single server is fine for development, and in production there's a huge struggle because no one ever tested the server running in a cluster.
Yes, indeed.
And if you have multiple microservers, you have the problem that if you have weak, MQ or not as available MQ system, if it breaks, everything broke, regardless how highly available your microservices are. If your MQ system or a queuing system or JMS system is not available, everything will break, right?
Yes, so that is one nice thing about Kafka, right? The fact that it's got the high availability built into it. So, even if one of the brokers crashes, you're going to have at worst a kind of a performance blip while leadership is transferred to another broker.
Exactly, but you will have to set up.
Then you get the complexity.
Yeah, but exactly, you will have to set up, Kafka from day one with multiple brokers and test it properly in container-like environment. Usually, this is what most of my clients are running, which is not trivial.
Yes, indeed, absolutely.
Yeah. And the same is true, of course, for MQ or MQS. But the difference is, in most companies, MQS is already running. So they know the whole business is running on MQS for years. So what you only have to do, to set up a JMS queue, and you are ready to go. And this is what I did several times in projects, suggested to my clients, and they were surprised how easy it was, just to run stock MQS or stock they already run then for batch processing and everything else. And we just reused some queues or topics for service-to-service communication, and this was surprisingly easy.
Yes, I think you're right. Yeah.
So
and I think there's one other thing which I think is probably kind of interesting to touch on here for microservices, and that's essentially the difference between queues and topics, because queues are typically easier to deal with in terms of the kind of the consumption model, but topics are kind of nicer because you get one-to-many publication, and I think that I normally would prefer to use topics for everything, but I like the kind of the capability of sharing a queue. And that's always a little bit of a challenge. I think certainly with Kafka, it's basically not possible to do that.
Yeah, I mean the killer use case for MQ or MQS was deliver once and only once. So the idea is that if you send something to a queue, what usually happens, the JMS stores the message in a single transaction in kind of store, and then in the subsequent transaction it is reread and the deliver attempt is made until the transaction commits. So this is the usual process of persistent queues, and from business perspective, this is what usually happens if you have some business transaction like payments. So you would like to send the payment order just once and not multiple times, and topics are more like broadcast. And I think the main difference is, correct me if I'm wrong, but in JMS and MQS, how it's called, durable subscribers and so-called persistence topics are more or less a bad practice, because you shouldn't do this. And queues, persistent or transit queues are just normal. So persistent queues from business perspective deliver once and only once, and transit queues if it can if you don't need the reattempts of delivery. And in Kafka, it's more like, we have topics which are always persistent. So this is almost the opposite of JMS, right? Or of MQS or any JMS server I know.
Yes, but I suppose the point I'm trying to make is that from the point of view of kind of the sender of the message, it's actually quite nice to use a topic. because that way you might have multiple consumers of the data, some of which you don't even know about yet. Who maybe you've got a business application that wants delivery, but actually you'd like to be able to log the messages to something else or send them off to an analytics system or something like that. So publishing onto a topic in a way that has the message handled in an exactly once way downstream is kind of a nice kind of blend of the two models. And you can of course do that with MQ, right? Because effectively a subscription is a proper queue, and you can do the assured delivery on that.
Yeah. So
Does that make sense?
Yeah, of course.
Yeah. So blending queues and topics, I think, is a pretty good way forward.
Yeah. So you have the. That's interesting what you said, because we had the requirements that the queue has to be consumed, the message has to be consumed only once. So if it is taken from the queue, no other subscriber gets the message. So like from business requirement, it's of course harder to achieve with topics, right? With persistent topics.
It is. Yes, that's true. But I think the people who are thinking like that, they're not necessarily looking at the bigger picture of the kind of, all right, well, what if you actually wanted to audit everything that went through this? Maybe you actually kind of want to feed off to the side, even though the business application is processing like a queue. So there are different ways of handling this, and some people have a kind of a slightly richer view of messaging and will think about it in a slightly broader context, I think.
Okay. And so what do you think is now still, the killer use case of JMS and the so would be of JMS or MQS, and the killer use case of classic Kafka?
So I always think of JMS as really just an API on top of a message queuing system.
Yeah.
So I don't think the API as such has a killer use case by itself. But having said that, it is the API that I tend to use if I'm writing a messaging application. So I like it. It's just an API. In terms of MQ, I think the killer use case is when you coordinate it with some kind of other system, and then you get transactional integrity in combination with something else. So if you're writing some business application that's using, say, a database and messaging together, then being able to coordinate the two resources together and commit them, using a distributed transaction is really nice, because it means the complexity of coordination is in the middleware rather than your application. So that's really good. For Kafka, it's all about event streaming. So the one you were mentioning earlier about IoT devices sending a vast amount of data and using Kafka as a kind of a concentrator, putting all the data from all of the devices on a single topic, and then scaling it as wide as you need to with as many partitions as you want, and having all of the data kept in order and reprocessable because it's all persisted is a really nice model. But it's very different from the kind of the business application, which is doing everything in coordination with another resource manager.
Mm-hmm. You already mentioned the two-phase commit or distributed transactions.
Yeah.
The interesting part of two-phase commit is because I think you are aware of XA. You did a lot of work with that, and what many people don't know, this is actually not always safe. So sometimes exceptions can happen. So like if you take a look at the XA exception, you will see that there are some like heuristic mix or heuristic hazard and heuristic rollback. So there some side effects can happen, and this usually happens if I think in the last phase one of the resources has a timeout or doesn't answer properly, right?
So I think the heuristic cases, for a correctly coded system, they only happen if something really weird happens. So typically, if a system goes out of contact for a long time and an administrative decision is kind of applied, saying, well, it must have been a rollback, and then the system comes back and actually it wasn't, then you've got a heuristic effect there where different parties have different views of what actually went on. Just a timeout, that shouldn't have any effect because it's designed to kind of retry. If you're in the first phase of two-phase commit and you fail to get to make contact, then you're going to roll back because of presumed abort. If you're prepared, then it should just retry forever, essentially. And if you don't do that, then you're kind of in dodgy territory.
Yeah. But it's the same feedback, right? You will have to, set up it properly, and you will have to also, to monitor and escalate XA exceptions to kind of, back out queue, whatever, and should wake up your administrator if something like this happened, right?
I suppose so, but I think I think my advice would typically be never take an administrative action. Right, the middleware is designed to eventually make it all consistent if it's just given the chance to kind of settle down and carry on communicating. And if you get into a situation where you're taking administrative action, you need to be sure that you've gone kind of the right way. You either do the commit or the rollback, and trying to work out which is the right decision is probably a little bit subtle. So it's normally better to get the system to work it out for itself. If you had some kind of integrity loss, you lost a disk drive or something like that, and you have to go in and deliver some kind of decision about the transaction's completion, then that's kind of unfortunate, but it should happen extremely rarely. I'm not really aware of heuristic effects in practice. Actually, they're kind of theoretical usually, I think.
Yeah, what I saw already is XA exceptions are just caught and completely ignored, so they were not handled at all, which is problematic. And what can also happen, of course, if you have application servers or transactions coordinators running in Docker, for instance, and they are coordinating two-phase commit, and if they break, the whole transaction log is lost.
Yes, okay.
So this is a complete different story if you're running in a distributed environment. But you are right. If MQS is set up properly and runs on the host system, and then it will work because everything is tested. In my world, it's like they starting an application and try to use two-phase commit and hope everything will work without any problems, without any testing, and just magically will happen. And then we get inconsistent systems. So it's a complete different world, yes. My world and yours. This is why it was also background of the conversation. Is like why we are misusing Kafka for having simple messaging, or sometimes even I saw the other way around. They used MQ to transport huge files for persistent, which didn't make any sense either.
Yes, I get that. So the very important thing about the distributed transaction is that everyone has to remember everything, and they all have to kind of do what they're told faithfully, right? So when you're told to commit, you have to commit, and that kind of thing. And if anyone is kind of forgetful, then it all breaks. So it's kind of fragile, and we use kind of high quality engineering to make sure that the system always behaves itself. But it does depend on not kind of losing data. So if you're running one of the participants in some kind of ephemeral way and it loses its recovery logs or something like that, then yes, it ceases to be reliable.
Yeah, if you think about this, what we covered so far is actually everything breaks, with not having persistence done right. So what we need is a simple but very high available and consistent persistence. If we have that, then we will win. But if we don't have that, then it starts to break, right?
Yes, that's right. Yeah.
And this is one of the challenges if Kubernetes-like environments, because your pods are usually stateless, so the state is just the local file system, which will disappear. So what you will have to do in order to set up Kafka or distributed transaction system on a pod is to write the persistent stuff to a folder, and the folder is then mapped by, I think it's called persistent volume claim by Kubernetes, to another location or somewhere else which is persistent. And this, of course, has to be low latency and very fast and so forth. This is actually the complexity which you will only see in production.
Yes, and I think you can build the right kind of environment with Kubernetes, but it does take planning and kind of understanding. So yeah, it kind of superficially looks quite simple, but it isn't in practice.
Yeah, so I think the gist of our conversation is don't run complex stuff by yourself. Try to either take something which is already installed in a company, so like distributed transaction manager or MQS or even Kafka, or buy it by clouds, because if you are in microservice environment and you try to set up Kafka within your project, or try to set up a JMS cluster within your project with the budget of your project, I would say this is a mission impossible.
Yeah, it's certainly challenging.
Okay. Do you have any thoughts on Java, Kafka, or MQS? Or
With regards to what precisely?
Your current work, for instance. Would you like to promote something or?
Oh, sorry. So I think most of the work I do currently is to do with people trying to exploit Kafka in kind of business context, and quite often with microservices actually. I think they do bump into a lot of the things we've been talking about here, with regards to safe delivery of messages and sharing topics and all this kind of thing. And I don't really think there is a silver bullet. One of the things I find is that people have often chosen Kafka in advance because it's kind of an up and coming technology, and then they try to work out how to fit their business problem around it, and it takes a lot of time to kind of do the conceptual education so that people don't kind of make a misstep, I think, and they kind of use the topics correctly. And of course we were talking about coordination of resource managers and that kind of thing earlier. I think I've lost you.
No, perfect.
Are you there still? No, sorry, I had call ended through my headphones, that's all. I'll try again. That put me off. Let's try again.
Yeah.
So people trying to use Kafka for microservices and not kind of understanding how you do things like consumer groups and sharing partitions and all this kind of thing, and how the scalability of the microservice depends on the way that you've deployed it on using Kafka resources, and then the fact that you're kind of in an eventually consistent world when you're using Kafka because it's an asynchronous API and that kind of thing, and the data stores used with it can't be coordinated with it, so you end up when you're trying to do things which use data stores and messaging together. Mm-hmm. Having to put the kind of complexity for coordinating these in your application logic. And that's a very different world than if you were doing it with MQ and kind of two-phase commit. So there's such a big difference between these technological approaches, and people kind of underestimate it quite often, I think.
Exactly. And in your opinion, what do you see in projects? Is Kafka running on bare metal, or are they running Kafka on Kubernetes?
So I think it depends. In companies that have got a very kind of high level of Kafka skill, then I think they tend to run it on bare metal, or maybe in a public cloud, but as an infrastructure as a service, mm-hmm. And they're taking control of deploying it directly. I think people who are kind of new to it will often try to use Kubernetes instead, or often use Kubernetes, sometimes with the help of somebody like IBM to provide them with an offering that has done the hard work already. So you just kind of click to deploy and you get a Kafka cluster. But yeah, I think we see both. And I think often with Kafka, it started off by a kind of a grassroots effort where somebody has started running it on a server they had lying around just to kind of get something off the ground, and then they have to try and move it into production. But it often comes from the grassroots like that.
Mm-hmm. And how you estimate the effort to set up Kafka without IBM? Let's say I'm a skilled Java programmer. I know a little bit about JMS, never saw Kafka, and I would like to run Kafka in production. So how many days should I try to set up, or what would your rough estimate to run Kafka in semi-production manner with some testing, stress testing, and several brokers? So how you will estimate the effort?
I think it would be several months to finish it, actually, not just a few hours or a few days in order to do it properly.
Okay, then
because
yeah, I was too
you have to worry.
Sorry,
yeah, I have to worry about the different failure modes and what happens if things fail, and if I lose a particular portion of the cluster, how does it recover, and that kind of thing. And one of the other things about Kafka is it's quite kind of network heavy because it replicates all of the messages. Mm-hmm. Then you need to make sure that the loads you're going to use in production can actually be accommodated by the infrastructure you've got in practice. If you start off with a little test that all looks nice, and then you kind of ramp it up, and you actually hit the saturation point of your network, then it's going to cause a throttling effect on the throughput you can achieve, which potentially you wouldn't have anticipated if you hadn't kind of done your calculations in advance. So it's quite a detailed thing to set up correctly if you look at all of the factors in play.
Mm-hmm. And you will also have to implement somehow the not split brain problem, but you will have to shut down one broker and see whether it recognizes that. So it's actually a lot of work, right?
Yes, and so I think the shutdown part of it is fine, but the other kind of aspect to it is, what about when you restart the failed broker? Because it'll kind of go into catch-up mode and try to replicate the data that was sent while it was down, and then eventually it'll kind of re-establish its leadership of the partitions it used to own. This replication traffic is going to be ongoing while your business applications are running against the cluster. So you need to have enough capacity in the system to kind of cope with the recovery mode processing as well as the forward, business application.
Mm-hmm. I think 10 years ago we had a system with 2 databases, and we found out when one database fails and then is offline for more than 5 minutes, we will never catch up because the network was too slow, to deal with the incoming transactions and data replication. This was actually interesting lessons learned 10 years ago. Something like this of course, happens with Kafka as well, right? That
It can. It can. Now, the other side of this is it is a very kind of cleverly designed system. So it has configurations you can set at many places in order to kind of limit the resource usage of particular pieces, so that you can ensure that you don't get an excessive application load, and that could give you sufficient capacity to make sure the system can catch up. But you're now getting into kind of highly detailed configuration, which only a really knowledgeable person would be able to do. So you can make a robust system. It's just it takes a long time to get the skills to do it, and of course you need to test that you've actually done it right. So that's why I said months to kind of set it up properly. Even though you can get it functional in a matter of hours, in order to kind of make sure it's bulletproof, it's much bigger effort.
Mm-hmm. I was too optimistic in the past, so last week I said we will need weeks if you really like to run Kafka in production properly. And they say weeks, okay, then we have no budget for this, but months. But absolutely with you, this is a piece of infrastructure which is actually has to be bulletproof. So there is not absolutely. And do you know about that similar offerings for MQS on Kubernetes or Docker?
So IBM makes provides resources for running MQ on Kubernetes and Docker. So we have things like Docker files on GitHub and that kind of stuff, and they are supported environments. And then we have a Kubernetes environment called IBM Cloud Private, and you can run MQ and also Kafka, and it's called event streams in that case. But you can run them both on our Kubernetes infrastructure as well. So it makes it rather more consumable. You don't have to do all the hard work yourself. So yes, that's entirely possible.
And if I would run MQ in a cluster, what is the difference to running Kafka in a cluster? So what MQ does behind the scenes to replicate the topics? Can you tell about that?
Yeah, so the idea, even though the word cluster is used in both MQ and Kafka, they're really very different concepts. So in Kafka, you don't really message directly with a broker. You're really doing your messaging with a cluster, with a collection of brokers who are together providing the messaging service. And the topology of the cluster is kind of a dynamic thing, and resources can move around, and the messages within a partition will usually be configured to replicate onto other brokers, so you have kind of high availability. But you're kind of connecting to the whole cluster, and it's doing the messaging for you. An MQ cluster is rather different because it's more like a kind of a collection of individual queue managers, and you're still working with one queue manager typically. There's a little bit of sharing of state between the queue managers to enable you to have queues with the same name hosted on different queue managers, but it's still rather more of a kind of client to server relationship, not kind of client to cluster, if you see what I mean.
Mm-hmm. Yeah,
it's kind of workload balancing rather than high availability, I think, in MQ, whereas that it's kind of the two are combined a little more tightly in Kafka.
So I used MQ once, and we had architecture like I had a local queue with, I think it was embedded MQ or something like this, where the messages were stored and the local queue was mapped to remote queue and replicated behind the scenes. And this was looked really nice, actually. You know what I mean?
Yes, I do. But you're still kind of talking to a queue manager, and then the messages are being distributed from that point, right? So yeah, it's a little bit different.
Yeah, of course. But what interests me, what MQ does behind the scenes, to keep the queues alive.
Yes.
So what happens behind the scenes? You know that?
But basically, there's kind of a directory of the cluster resources, which is managed by special queue managers called the repository, and the queue managers, which are kind of non-repository, not full repository queue managers in the cluster. They kind of internally subscribe to the information from the full repository, so they understand which resources sit where, and then when you're making your application calls against the queue manager to put to their cluster queue, it can work out where that queue is hosted based on this kind of view of the repository's data. So that's sort of what happens behind the scenes. Now, in a Kafka system, it's very, very vaguely similar idea in that you can kind of ask questions about where resources live, but the data goes directly back to the client in that case, and it doesn't have this kind of intermediary requirement to go through a particular broker to send messages. So, a little bit different in terms of how they work behind the scenes. But at the end of the day, you've got this kind of workload balancing in both those ways.
Yeah, both are. MQ reminds me on consistent hashing, so you know where the data lives. Exactly, the shared resources.
Yes.
Okay, perfect. So, any final thoughts on both, or?
I think go back to what we said originally. There are these two kind of different models of messaging: the message queuing and the event streaming, and they're kind of two ends of quite a broad spectrum of messaging. And an MQ is kind of specialized for one end, and Kafka is specialized for the other. And when you're kind of in between the two ends of the spectrum, then you kind of have the freedom to choose either technology. You just need to be careful to make sure that whatever you do is kind of sympathetic to technology you choose.
Perfect. Also, where people can find you? So, do you have a Twitter account or GitHub or IBM account or whatever?
I don't use Twitter. You can find me on LinkedIn. So Andrew Schofield, and you'll find me quite easily as an IBMer on there. I'm the author of IBM's connectors between Kafka and MQ for Kafka Connect. So I've put those on GitHub. So if you search for Kafka Connect MQ source or Kafka Connect MQ sync on Google or another search engine, then you'll find my repos on GitHub, or just email. So andrew_Schofield@ukibm.com.
So thank you. Thank you for the clarification. It was a really great talk, to find the differences between both architectures. So thank you.
Okay, you're welcome.